Hello students, in microprocessors interfacing course, the tutorial of module 4, you had a question to add the nibbles of a data byte and check for the carry, and if there is a carry, you need to update the memory location with the character C, or else that memory location will have a character N. So yes, you have understood what exactly to be done is, you have the data set like 45H, 64H. Suppose you have declared a data set something like this. Right? You have declared data set like dat 1 dB. So you have declared data set like 45H, 99H, 69H, 21H, 33H, 1, 2, 3, 4, 5, 6, 7, 8. Imagine I have declared an array of 1, 2, 3, 4, 5, 6, 7, 8 bytes. See, what exactly you have to do here is, you have to write a program, you have to write an assembly level program which will add the two nibbles of a byte. Add two nibbles of a byte. Suppose if we take this 4, 5. Suppose if we take 4, 5, you have to separate this 4 and 5 and add this 4 and 5, and you have to check for a carry. Now suppose if you take this 9 and 9, and when you add 9 and 9, you get a carry. Now 4, 5, 0, 9, you may not get a carry, but when you add 9, 9, you get a carry. How to check this? Now suppose if you separate this nibbles. So imagine if we have separate this byte into 0, 4 and 0, 5. If you separate this 0, 4 and 0, 5, right? So when you try to add these two, right, it is doing a byte addition. It is not doing nibble addition. If you use add instruction in this, it is doing byte addition. So when you add this single digit, that is two single digit number, see this 0, 1, 2, 3 all is normally single digit. When you add a number like this, you will never get a carry using this instruction. Now our purpose is not an addition here. Our purpose is to check whether there is a carry. So what we will do is, we will try to separate it, right? And then we will make a data like this. This 45, we will make it as 40 and 50. When you make this, when you convert this into these 40 and 50, so what happens? When you add this, this will generate a carry. This will be 0 and this is 90. In this case, there is no carry. But suppose if you take this 90 and 90, if you do this, so this will definitely generate a carry here. So this will generate a carry. This is a byte addition. When you use add instructions with this is doing a byte addition and it will give a carry. So in this way you can check the carry when you add these two nibbles. So this is one nibble of this 99, this is another nibble of this 99. Similarly, the same thing is done for all the numbers in this array. So we will follow this logic and we will try to write a program for this. So how do we proceed? How do we proceed with this now? As usual, we'll start writing a program. We start with the dot model. Start with dot model. Dot model small, and we'll start with the data. Start with the data. Okay, and we'll declare our date one db. So we will declare in this case some 10 numbers. 45h, 67h, 99h. 4 data is over now. 67h, 55h. Some number you can put it. Okay, 88h. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what you did, you declared an array of 10 data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data. Right? Now we declare another array called as carry 1 of data byte. Carry 1 data byte. See, I'll make 10 and I'll initialize it with capital N. Initialize it with N. Right? Later we can write a program in such a way that if there is a carry, change the content with C. Otherwise it will remain as N only. We'll use that logic and we'll write a program for this. Fine. So if you want to put count, you can put count, okay, db and 0, 0, 0, AH. This is the count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers are there. So I'm putting 0, 0, 0, AH. So now this completes your data part. So write dot code, then write start, and then you write move as usual, move ax comma at data. Now move ds comma ax. Why we are doing this? We are going to bring in the data, the address of the data segment into present program. Hope all of you understood this. Now what you do is, now you just put that count into the CX register as usual. Count into CX register. So move CX comma count. Now let us have an index register. So we will use SI comma, I initialize SI with 0, 0, 0, 0, H. Right? Okay. Now next we have to access the data. Right? Now what we will do, the ASCII value of the character C, we will put it in some register. What we are supposed to do? We are supposed to, if there is a carry, we are supposed to put the character C in this array. Right? See, if there is a carry from any of the number, corresponding location will have C. Otherwise it will have N. See, for example, in this array, char1 array, this is not going to generate any carry. This will have N. This will have N. Right? This also will have N. But this will have C in this. So wherever carry is generated after multiplying these two nibbles, the corresponding location in an array char1 will become C. That C, we will put it in one register. So what we'll do, we'll put that move, we'll put in DH register or DL register, we'll put that ASCII value of C. Later we will use this DH register to move the character C into particular memory location. Right? Okay. So now what we will do? Now we will take a first data. We'll take a first data. So which is pointed by the SI register. So what we will do? Move AL. This is a byte, so we'll use the AL register. Okay. So it is dat1 of SI. Dat1 of SI. Right? Okay. Now what is there in AL register? The first number, okay, that is 34 is there in the AL register. Now what we will do is, I will just mask, okay, the lower bit. Okay, I'll just mask the lower bit. Okay. Before that, I will keep a copy of this in AH register. Before that, I will keep a copy of this in the AH register, because later we need the data to get the another nibble. So I will keep a copy of this in the AL register. Fine. So why I am doing this? Whatever data is loaded from this memory location is there in AL. I am keeping a copy of this. So now I'll just mask the lower bit, okay, by ANDing this content of AL, ANDing the content of AL, okay, with 0FH, by ANDing the content of AL with 0FH. See what happens? What happens in this case? What happens? See, suppose you have, see what is the data which is read now in the first iteration? The data which is read in first iteration is 34, right? So content of AL register is 34. When you AND it with 0F, okay, so 3 ANDed with 0 is 0, 4 ANDed with F, that is your 4 is 0 1 0 0, and with 1 1 1 1, what you get? 0 1 0 0 only, right? So you get 0 4. So your AL register is having 0 4. Hope all of you understood this. This is called as masking. Okay. Similarly, how do you mask the higher bit? The higher bit can be masked by using the same data 3 4. If you mask with F0, so what you get? You get 3 0. You get 3 0. Right? Now what happens is, now next what you do? Now and get the higher bit. Now and AH is also having same content, right? And AH comma 0F0H. It is same as this one, right? See, but actually what you want out of this? You want this 3 4 to be converted as 3 0 and 4 0. Then you do the byte addition and check, is there any carry between these two? That is what you want to do. So now what you have to do? Now AL register is having 0 4. How do you make it into 4 0? You rotate this for 4 times. When you rotate this for 4 times, this will become 4 0. So now what you do after this is rotate AL register, rotate AL register. How many times? 4 times. 4 times. When you rotate AL register 4 times, what will happen? This 04 will become 40, right? So then it will come to proper format 30 and 40, and whatever carry is generated from these two, okay, based on that you can test the carry by using jump on carry or jump on no carry and decide what to put into array CAR1, in this CAR1, right? So hope all of you understood this. Now next is add, right? After rotate AL 4 times, you get this 04 has become 40. So now you add these two. So now add AL comma AH. AL comma AH. Right? AH, there is no problem. AH directly you get the higher bits. AL you have to rotate. Whichever is masked using 0FH. Right? Okay. Now with this operation, then may be carry generated. With the operation there will be carry generated. Okay. So now what you do is, if there is no carry, okay, now what you do, you go to next. If there is no carry, you go to next, right? So what the next has to do? Next has to simply increment, okay, next has to simply increment, okay, it has to simply increment, okay, next colon, it has to simply increment SI, right? So now if this is not satisfied, if there is a carry, what you should do? You should put that C into the array, right? Now what you do? C is already the DH register. DH register. So now here you should put move char 1 of SI, comma DH. Move char 1 of SI to DH. So what will happen here is, if there is a carry, now what happens? That particular location will be loaded with C. Otherwise it will remain with N. That location will have N if there is no carry. Okay, so now increment SI. Okay, now what we should do? We have done one number, right? Same thing has to be done how many times? 10 times, right? So increment SI. Okay, now what we should do next? Loop, right? Loop statement. So next write loop. Okay, so I'll write repeat. Loop repeat. Where the repeat should go now? After incrementing SI, where the loop should go? Now loop should go to the repeat. You should put the repeat, okay, label here. Repeat label, repeat. The repeat label will come here, right? So now what the loop statement will do? Loop statement will automatically decrement content of CX register and check the content of CX register. If content of CX register is 0, then it won't go to the repeat. Now if the content of CX register is not 0, it will repeat, it will come here. So when it comes here, SI is incremented by 1. Now SI is pointed to the next data. SI is pointed to next data, 45H. Now once again, it will convert that 45 into 40 and 50 and add and check if there is any carry generated from these two, right? And then SI is incremented once again, right? And then next data is 67H. Here also you may not get carry, but when it load 99, you get a carry, right? So what you get is 90 and 90. You get 90 and 90. So definitely you get a carry out of this. Now if there is a carry out of this, that means when you add two nibbles of 99, when you add, these are the two nibbles, okay, when you add this, you have to check whether there is a carry or not. This is possible only when you do a byte addition by converting it to 9090 like this. So when there is a carry out of these two, okay, the carry flag will be set and you check jump on no carry. If there is a carry, it will put that character C which is copied into DH register will be copied to the memory location char 1. And this will be done how many times? Until your CX register becomes 0. And CX register is loaded with count value. That's count is nothing but 10 here. That is 000A. So now after this, once everything is done, you end the program. So you just give integer 3. Okay. So now to halt, there are other options which I told you. You can also use move AH, 4CH, and also you can use the interrupt 21H. This is the different interrupt. You will understand when you come to the interrupt chapter. So hope all of you understood this. So kindly see this video repeatedly and try to understand how the question number 6 of tutorial on module 4 can be solved. So if you have any doubt, please write to us. You can write to any of the tutorial faculty and clarify your doubts. The same program can be written different way. In the solution provided to you, you are having statements such as LEA, right? LEA. What is it? LEA. This LEA is called load effective address. Load effective address. See, what happens is, it is possible to use this index register with the address of the data stored in the data segment. We need not use it as an index register. For example, I will tell you. For example, right? This load effective address, what it does is, suppose you have declared a data, say num db 67h and 68h, something like this, right? Now suppose if you use instruction load effective address, okay, say I will use the same si comma this num. What it does, the address of num itself is stored in the si. In such case, what you can do, in such case you can just use a statement move, okay, al comma si in the square bracket, right? Si in the square bracket, right? This is also a correct way of using it. The same thing, normally we write it like this. Instead of this, what we do, we use move si comma 000h. Then what we do, move al comma num of si. Both does the same thing, but it does in a different way, right? Now similarly, there is one more instruction. You can see load SB. This is called string instruction. You will see it in a video when you see the string instruction video. So what it does, right? So this will load content of the memory location, okay, to AL register. Which content of memory location it will come? Content of the memory location which is pointed by the SI register will be loaded to the AL register. So see how many things will happen automatically in this. See, this load SB, the one instruction, what it does, it will load the content of the memory, okay, where the address is stored in the SI register to the AL register. Right. Suppose, imagine that I have a statement something like load effective address SI, comma num. Now SI is having address of num. Suppose after this, if you execute this instruction load SB byte, after execution of this, you can see your AL register is having this, the first content of num. This will automatically happen inside this. Now after this, automatically SI content will be incremented by 1. Once it is loaded, next SI will be the next value. Automatically it will happen, provided that direction flag is equal to 0. When direction flag is equal to 0, automatically SI will be incremented by 1 once this instruction is executed. If direction flag is equal to 1, this SI will be decremented by 1. That is the specialty of this load SB instruction. Right? So this can be done by clear D, CLD instruction. Okay, STD and clear D will clear direction flag, STD will set the direction flag. So you can use DF is equal to direction flag can be made 0 and direction flag can be made as 1. Right? So these direction flags are used especially in this string instruction, which we can discuss in the string instruction part. Fine. So hope all of you understood this. So the solution of the program, this video you can repeatedly watch, and if there is any clarification doubts, you can just email me or you can just send me a message to clarify your doubts.